Welcome back, Focus Learners. Let's jump right into today's explainer. If you've been paying any attention to the AI space lately, you and I both know that large language models are absolutely incredible. But they have a pretty fatal flaw. They hallucinate, and they definitely don't know your company's private data. Retrieval Augmented Generation, or RAG, was the huge breakthrough that fixed this by actually connecting AI to external knowledge bases. But man, this technology has moved incredibly fast. Today, we're doing a complete deep dive into the evolution of RAG. We're going to look at how it transformed from those basic, kind of naive prototypes just a few years ago into the highly complex, agentic, production-grade systems that are literally powering the enterprise in 2026. Let's get into it. Okay, so here's our quick roadmap for the explainer today. 1. The evolution of RAG. 2. RAG in the real world. 3. The production failure problem. 4. Evaluating AI in production. And finally, 5. The final summary. Section 1. The evolution of RAG. From naive to agentic. It is actually fascinating to trace how this concept has progressed. We started with naive RAG. Think of it as the classic hello world of AI. A user asks a question, the system retrieves a document, and the AI generates an answer. Boom. It was simple, sure, but way too rigid. Then we evolved to advanced RAG, which added these really crucial layers like query refinement and re-ranking to prioritize the absolute best information before the AI even saw it. From there, we got modular RAG. This was a game changer because it treated retrieval like interchangeable Lego blocks, intelligently routing queries to different databases depending on what was actually needed. And finally, sitting right at the cutting edge in 2026, we have agentic RAG. We've completely moved beyond basic open book tests here. Agentic RAG acts like an independent AI researcher. It performs complex, multi-hop retrieval, it picks different tools for different parts of a layered question, and, crucially, it self-checks its own draft answers. If it spots a hallucination, it goes right back to retrieve more data. Now, there are some absolutely crucial engineering trade-offs you have to consider here. Think about the naive architecture. It has low complexity and low latency, meaning it's super fast, but its accuracy is, well, just medium. It's great for simple customer FAQs. But on the other hand, agentic RAG gives you very high accuracy, which is non-negotiable for complex reasoning tasks like financial analysis or medical diagnosis. However, the trade-off: very high complexity and high latency. Basically, you're sacrificing speed to ensure the AI doesn't make things up. Section 2. RAG in the real world. Enterprise deployments. To see how this actually works in practice, picture a real-world setup like the CMIG Energy Sector Audit Platform in Brazil. You have a highly structured flow. You start with the application layer, handling the front end and session state management. Then user queries move into the data layer, where they're converted into embeddings and compared against a massive vector database of insanely complex regulatory documents. All the while, an MLOps layer is continuously pre-processing and chunking brand new legislation, so the system is always up to date. This isn't just some weekend toy prototype. It's a highly modular, secure enterprise architecture designed to deliver precise, reliable information in a heavily regulated industry. So the real trick is knowing exactly when to deploy which architecture in these real-world scenarios. It often comes down to choosing between standard RAG and a really powerful variation called corrective RAG, or CRAG. Here's the deal. If your company's documents are pristine, well-structured, and consistently formatted, standard RAG is usually perfectly fine. You get low latency and a much simpler architecture. But let's be real. Most knowledge bases are messy, noisy, and mix totally different formats and ages of content. That's when you absolutely need CRAG. Corrective RAG adds this brilliant retrieval evaluator step. Before it ever generates an answer, it scores the retrieved documents. If the confidence is too low, it immediately triggers corrective actions, like filtering out irrelevant details or even running a fallback web search. It's basically a bouncer, ensuring the AI doesn't generate an answer based on garbage data. Section 3. The production failure problem, the hidden dangers. I have to share this quote because it really jumped out at me. Too many teams are still operating on vibes and vibes alone. When you build a simple RAG prototype, it's so easy to just test a handful of questions yourself, see a good answer, and think, yeah, that feels right. But let me tell you, relying on a gut feeling and manual spot checks instead of real metric-driven development, that is a complete recipe for disaster when you try to scale. And the stakes are incredibly high right now. By 2026, RAG powers an estimated 60% of all production AI applications. We're talking everything from customer support chatbots to highly sensitive internal knowledge bases. If you're operating on vibes at this scale, your production failures aren't just a minor annoyance, they are a massive, costly business risk. Let's actually break down what these failures look like in the wild. You've got under-retrieval, where the system just totally misses the right document. You have hallucinated citations, where the AI just completely invents a source. Then there's state contamination and tool misrouting, which is when the agent inexplicably decides to use a web search when it really should have just queried a private SQL database. But you know what the most surprising issue is? Over-retrieval. This is a huge problem in agentic RAG. An agent can get stuck in this endless reasoning loop, calling the retriever 8 to 12 times for a super simple question. It burns massive amounts of tokens, totally destroys your latency, and often actually surfaces a worse final answer because the generator is just drowning in way too much context.
Section 4. Evaluating AI in Production, Systematic Frameworks.
And that brings us perfectly to RAGAS. RAGAS stands for Retrieval Augmented Generation Assessment. It is an absolute game changer. It's a framework for the automated, reference-free evaluation of RAG pipelines. Why is this so critical? Well, traditionally, evaluating AI meant paying humans to slowly read and annotate thousands of answers, which, let's be honest, sounds like a terrible time, right? RAGAS instead uses LLMs as judges to automatically test the quality of both the retrieval process and the generation process, without needing a slow, manual ground truth dataset. So how does RAGAS actually measure quality? It breaks everything down into independent core metrics. First up, faithfulness. Is the generated answer actually grounded in the retrieved context, or is the AI just hallucinating facts? Second, context relevance. Did the retriever pull highly focused information, or did it just grab a bunch of irrelevant noise? And third, answer relevance. Does the final answer actually address what the user originally asked? By measuring these things independently, when your system inevitably fails, you'll know exactly whether you need to go fix your retriever or fix your generator.
Notice the massive shift in how we actually deploy these evaluations now. We're moving completely away from traditional batch evaluation, which was episodic, isolated, and totally relied on those manual spot checks. Instead, the 2026 standard is continuous production evaluation. Using amazing platforms like Braintrust and AI Veta, evaluation is integrated directly into the CI/CD pipeline. Every single user interaction is traced. And here's the real magic. When a production failure happens, it is automatically captured and turned into a test case for the next deployment. You're completely closing the feedback loop.
Section 5, the final summary, your actionable playbook. If you are building these systems today, here is your definitive 2026 Agentic RAG playbook. Step 1, pick a framework that fits your team, whether that's LangGraph, Llama Index, or the OpenAI Agents SDK. Step 2, wire in observability from day one. You literally must trace every single span of execution so you can see exactly what the agent is doing under the hood. Step 3, attach evaluators like RAGAS directly to those spans to score faithfulness and relevance automatically. And Step 4, run a 100-query golden set. Just run your toughest, most complex questions through the system, review the failures, and let the data tell you exactly which architectural patterns you need to add to actually reach production-grade reliability. Which leaves us with one final critical question for you to really think about. Is your RAG system running on actual data or just good vibes? It is time to audit your pipelines, implement some rigorous evaluation, and ensure your AI is actually delivering the accuracy that the enterprise demands. Thank you so much for joining me on this explainer, and I really hope this structured deep dive helps you master RAG in 2026. Keep learning and keep building.